Let's take a look at something called precedence and order of operation. Precedence and order of operation is important, but I don't want you to be scared off by it right now. I'm going to show you a table here on the next slide that it looks awfully complicated, but in some ways it's just common sense. If you don't understand precedence and order of operation, then you can get into issues where there are problems occurring, but you don't know why. Maybe mathematical outputs are different than you really believe they should be, or that you've even calculated by hand. But again, you don't know why they're off. Precedence and order of operation can do that to you. For example, let's take a look at this. Here we have an array called A, and it's going to have a bunch of elements in it. Like, let's imagine that this sentence is an array, which if this was a string in the C language, it would be. So here's the first element, which would be A sub 0, is this letter C. And then there's A sub 1, sub 2, sub 3, sub 4, as you go out across this string. And remember, hello world, that was a string. The H was at sub 0 at the very first element, and then there was another letter, and so on. That's the same thing we have here. So here's this little array called A, and some element here, I, this is a variable, and it could be 0 through whatever this number would be out through here. If we want to take that value and increase it by 1, this number in here, this index, we are saying that A sub I is equal to that value incremented. So we're saying that whatever is in a particular location that is referenced by I, 0, 1, 2, 3, whatever I is going to be equal to that value of I incremented. Well, here's where precedence and order of operation gets us. Which I are we going to use in here? I before it is incremented, or I after it is incremented with the plus plus, the post increment operator? Well, this is not specified by the C programming language. It is up to your compiler and up to how your compiler works with your particular computer to decide on the best way to do this. Bottom line, don't do this. You would want to increment I someplace else, or read the value of I out of this other variable or some other place in your program, then increment it, then use it as an array subscript. You would not want to form a statement like this because it is so arbitrary, and it is leaving decision making up to your compiler, which you don't always want to do. Same issue down here. Here we're saying that the value of x is equal to the result of the function f. F is going to be called, and then some result will come back from the f function, added to the result of the g function. We're going to call this g function, and it's going to do something and give us a number back. So these two numbers will be added together and then put into there. If f and g both work on another variable, and that variable is affected incorrectly, if f is called first or g is called first, then we're going to have a problem because we can't tell the compiler which one of these to do first. It will not necessarily do this function call and then this function call. It might decide to call g first and execute the statement this way. We can't tell the compiler which one of these two expressions to do before the addition. And then, of course, that will all happen, and then the result will be assigned into x. That we understand. So if you're going to do something like that, you need to make sure that f and g don't bother the same variable between them, that they don't cross paths, because we cannot determine which one of them is going to win this foot race. That is precedence and order of operation. Now let's take a look at this next table here. And this is in the K&R book and many other C programming books that you'll find. This is the typical order of operation. So you can see that operators like the function, parens, array, subscripts, these we haven't talked about yet. They're going to deal with structures and pointers and things like that. We'll get to them in future chapters. And here we have several other operators that we've already looked at. This one we haven't looked at yet either. That's a little different animal right there. Then the type and size of operators. We've looked at type when we talked about typecasting, but we haven't seen size of yet. So some of these are unknown to you, and that's okay. I promise we'll get there. And here's all the different, here's our bit shifts we looked at, and comparisons, less than, equal, and so on. And the order that they are associated, left to right, right to left, how you read them when you see them in a statement. And here's our unary operator for the binary and exclusive or. And here's our logical and logical or. This is the conditional expression we just looked at. Remember the question mark and the colon, and it's read right to left. And here's some of our assignments down here, and this one continues on. That's our bit shift right. And then the comma operator, we're going to see that very shortly. We haven't looked at that one yet, but it's pretty simple. So that's our order of operation and precedence table. Again, you won't really need it unless you get into some pretty complicated programming that is going to depend on the order of operation. And hopefully you won't be there right away, especially not in the as you begin learning the C programming language. But again, I do want you to be aware of it and that there can be issues so that you're not really scratching your head and then eventually pulling your hair out at 2 o'clock in the morning trying to fix something. So just be aware of this, and let's move on.